Welcome to qnawire.
To construct a 99% confidence interval when the population standard deviation is not known, we use the t-distribution. And we know that the sample mean is 820, that the sample standard deviation is 25, the sample size is 23, so the degrees of freedom is 1 less than that at 22. For 99%, our alpha then is 0.01, and our critical t would be 2.8188. And so the 99% confidence interval would be the sample, well, I'll write it out. The sample mean plus or minus the critical t times the sample standard deviation over the square root of the sample size. And so that'd be 820 plus and minus 2.8188 times 25 over the square root of 23. And so our lower boundary to 3 decimal places would be 820 minus 2.8188 times 25 over the square root of 23, which would be 805.306, to an upper boundary of 834.694. For part B, we're going to assume that the standard deviation was 50 instead. Everything else is going to stay the same. Same mean, same t, critical t, but the standard deviation is now 50, meaning the data is more spread out. How does this affect it? Well, the lower boundary would then be 790.612, and the upper boundary would be 849.388. And then for part C, if you're going to change the standard deviation to 100, so that'd be 820 plus or minus 2.8188 times 100 over the square root of 23. Lower boundary is 761.224, and the upper boundary 878.776. So for part D, what happens what happens to the interval as S increases? Well, the interval keeps getting wider and wider or wider as the lower boundary keeps getting lower and the upper boundary keeps getting higher. So I think you have that one correct.